It's really cold out, yeah.
I don't think I've been outside for 4 or 5 days.
I haven't either. Yeah, you're not alone.
There's no reason to go out when it's that cold.
Ah, seriously.
No need to.
Uh-huh.
Uh,
Nope. There's no reason to.
Yeah. Okay.
Yeah.
I have taken some problems from the
Uh-huh.
end of the chapter on quads
Okay.
that I thought we'd just go over. And I'll pick and choose
Okay, definitely.
which of these to do. And it's possible you've done some of them that won't hurt anything.
Uh-huh.
Tell me what we're going to do on number 2. You don't need to give me the answer. Just tell me the strategy.
360 minus, however, minus like what the three numbers equal.
Okay, cool. How about number 3?
For number 3, you'd set 1/2 y equal to 4, and then 5x minus 3 equal to 3x, or 5x minus 6
Correct. Correct.
equal to 3x. Okay.
And what kind of figure is that on 3?
Parallelogram.
Good. Number 4. Solve for x and y.
So x would be equal to 110, then y would be equal to y, I guess. Or like
y is always equal to y, but what number is it?
would y be 180?
Always check the angle to make sure that that answer makes sense. In other words,
yeah.
don't be so quick to come up with an answer, especially if you think you're guessing. If you think you're guessing, take just a little bit more time and see. Well, that doesn't look like a 180-degree angle.
No, it doesn't.
It doesn't even look 90.
No, it's less. It's an acute angle.
So what's the relationship between y and 110? What are we looking at here? What kind of shape?
A parallelogram.
Okay, so that line's parallel to that line, which makes y and this angle, what kind of angles? If I have two parallel lines, we're looking at one angle there and another angle there. What's the relationship between those two?
They're corresponding.
Okay.
Well,
what's important? They're not really corresponding.
No.
Corresponding would be this one.
Yeah.
In other words, this one and this one would be equal and corresponding. So if they're not equal, what are they? When you're dealing with parallel lines, there's only one other thing.
Adjacent?
Yes. What are adjacent angles?
Adjacent angles
are,
well, they're supplementary.
That's it.
Yeah.
The two things you need to know about parallel lines and transversals.
Okay.
Either you have equality or you have supplementary.
Okay. Cool.
Okay? And never forget that when you're looking at a parallelogram, you're looking at parallel lines. That's parallel and that's a transversal. And you could flip the thing 90 degrees, and that's parallel, and these are both transversals.
Okay.
Okay?
Okay, cool.
All right, number 5.
All right. Ooh. How would we set that one up?
Well, first of all, what are we looking at? What kind of figure?
Would that be a rhombus or like parallelogram?
If it were a rhombus, what would these hash marks all be?
Supplementary.
They would all be the same. They would all be single hash marks.
Yeah.
In other words,
so we're looking at
when you see a single hash mark and a double hash mark, that means those two sides are not equal.
No.
If they were, they would have single and single or double and double. So what we're looking at is this side's equal to its opposite side.
Yeah.
And this side is equal to opposite side. What kind of figure is that?
Parallelogram, then.
Correct.
Yeah.
Doesn't say they're parallel, but just because if you have opposite sides being equal, you can't draw that without drawing a parallelogram.
Okay.
Now, what do we know about the diagonals?
About the diagonals. Well,
In other
they
words, first of all,
bisect
let's talk about what is that measurement
of
of? Is it an
that
angle or a
line
side?
segment.
Is that a line segment or an angle?
Line segment.
Same thing that?
Yep.
What is
Yep,
that?
that's a line segment.
And what's that?
That'd be a line as well. Like a line.
Yeah, that's
Well,
a line segment. No, because there's no degrees. Notice
no.
that in problem 4, when they were looking at an angle, they show a degree sign.
Okay.
Now, if there's no degrees, even if it's a variable, then it's a line segment.
Uh-huh.
Now, it's not completely clear which line segment, but
Uh-huh.
we'll see if we can figure out which line segment they should be talking about. But
Okay.
if I draw a parallelogram,
Uh-huh.
what does it look like the diagonals do?
Well, they don't. Yeah, they'd form a 90-degree angle.
No, they don't actually.
They don't. Okay.
Watch if I want to answer that question, because that's a legitimate question. They do if it's a rhombus.
Okay, that makes sense.
If it's a rhombus, but if I draw an extremely long parallelogram, you can see that they don't form a 90-degree angle.
Yeah, you can.
Yeah, that's a huge. That's not 90 degrees.
No, I don't think
But
so. Yeah.
no matter how long I draw it, they do appear to do something else.
Okay.
What?
Well, they bisect each other.
They bisect one another. So
Okay.
rectangles, squares, rhombuses, and parallelograms, the diagonals will all bisect one another.
Okay.
Okay?
Cool.
So, but only rhombuses and squares are they perpendicular at the
Okay.
and kites, but kites aren't your standard parallelogram.
No, they're not.
They're
Yeah.
not standard diagonals either.
Yeah.
But okay, so what can I say here about all these things? We want to solve for x and y. So what's 2y equal to?
2y would be equal to 7, right?
Yep.
Okay.
And what
then
is x plus 6 equal?
that'd be equal.
I gotta believe that x plus 6 is this side right here.
Yeah, me too. It only makes sense.
For one thing, they don't give us enough information to solve for this side. We know 7 and 10, but we don't know this angle and we can't figure it out.
No.
It's merely a parallelogram where this side's longer apparently than this side, which means we don't know that angle, which means we don't know that side.
Yeah.
But
exactly.
So therefore, the x plus 6 must be referring to that half diagonal.
Yeah, so it'd have to be equal to 10.
Right.
Okay, cool.
What's that?
Number 13.
Uh-huh.
Quadrilateral.
Okay.
Yeah.
Can you solve? No, it's more than a quadrilateral.
Would it be
based on these right angles?
2 right angles.
What kind of angles are those? If I'm looking for parallel lines, what would the angles be called?
Like perpendicular angles.
Are they corresponding? Are they adjacent? Are they alternate interior? Are they alternate exterior? What are they?
Adjacent.
Okay. Think of this thing. Remember that if that line is parallel to this line, then adjacent angles are supplementary.
Okay.
But the corollary to that is, if you have adjacent angles that are supplementary, then that line is parallel to that line. In other words, so we know that this side is parallel to that side, even though they don't state it. As long as that angle is equal to that one, or it's not equal actually, as long as this angle is supplementary to this one, and this line has to be parallel to that line. So what kind of shape is that?
Then that'd be a rhombus, wouldn't it? Well,
you need to be looking at your flashcards.
Yeah.
To me, when I hear the word rhombus, first thing I think of 4 equal sides. First thing.
And then that one only has 2
about
equal
all the angles, I don't think about any of that. I think about 4 equal sides when I have a rhombus.
Okay.
Okay? And it can take the shape of all kinds of things, but not this.
Yeah.
First of all, if I have 4 equal sides, it has to be also a parallelogram. Okay?
Okay.
So what's the 6th quadrilateral you learned? You learned squares, rectangles. There you go.
Yeah.
That is a trapezoid because it has one and only one opposite pair of parallel sides.
Okay. Okay.
What's the area of that trapezoid?
The area would be... How would we find the area? Oh, the area. Oh, my bad. Yeah, so that'd be base times height. Well, B1 times B2.
Okay. You're on the right track. I like the fact that you memorized it as base times height.
Okay.
Because the next step, when you think base times height, that's rectangle. But it almost applies to quad or trapezoids also. What's the base?
The base would be 19.
Or 11. Which one?
Or 11, yeah, either one, yeah.
Not either one. The area is going to be one or the other.
Oh.
So what has the area formula be?
B1 times B2, right?
B1 plus B2.
Oh, plus B2.
Divided by 2. In other words, you want the average base times the height. That's the way to memorize the formula for trapezoids. Area is the average base. Well, there's only 2 bases. The bases refer to the sides that are parallel. Okay, so that's the midsegment.
Okay.
That's the average base, right? So what's the midsegment going to be? The length of it.
The midsegment, that'd be 19 then, wouldn't it? Because that's, well...
Add these 2 numbers together and divide by 2.
15.
Okay. So it's 15 times 9. In other words, it's almost easier to memorize the area formula as the midsegment times the height.
Okay.
Because that's what B1 plus B2 divided by 2 is the midsegment.
Okay.
Okay. Number 14.
Number 14 would...
Yeah, I got a glare here. It's covering up some of the stuff. But
no, it's okay.
So...
That would be a kite, wouldn't it? Well,
no,
yeah.
Very good. Very good.
Cool.
Or is it a rhombus?
No. Well, I guess it could be a rhombus, couldn't it?
Well, let's find out.
Okay.
For it to be a rhombus, that side has to equal that side has to equal that side has to equal that side.
Yeah.
Well, if I have a triangle here, just taking one of the triangles that's 9 by 12, what's that?
If it's 9 by 12,
always be thinking 3, 4, 5 triangles.
Yeah.
Because that's what they give you most of the time. They don't want you spending your time having to do the Pythagorean Theorem all the time. So they give you simple triangles. This is a 3, 4, 5 triangle, a multiple.
Yeah.
Well, this side isn't 3, it's 9. This side isn't 12, it's 4. This side's not going to be 5. What's it going to be?
6, right? Or no, 8. That'd be 8.
What's the multiple of 3, 4, 5 that we're dealing with?
3, 4. So that's
here's our normal triangle.
3, 4, 5. Yeah.
What's our similarity ratio? This triangle here is incidentally similar to our 3, 4, 5 triangle.
Uh-huh.
Meaning the proportion of all sides is going to be the same. Well, that's 3 to 1. That's 3 to 1. What's 3 to 1 over that?
Would that make that 10 then?
What's 3 times 5?
15. So that's how it'd be 15.
So that is a 3, 4, 5 triangle. It's just a multiple of a 3, 4, 5 triangle.
Okay, that makes sense. Okay.
Now we notice that every triangle in here has those same dimensions. 9 by 12, 9 by 12. That means every side is 15.
Okay.
That makes it a rhombus.
Okay, cool.
4 equal
so it can
sides,
be both, yeah.
4 equal sides, and they meet at a right angle in the middle.
Uh-huh.
That's a rhombus.
Okay, cool. Okay.
Now, the instructions here said what special type of quadrilateral is shown. So you want to use, this incidentally is also a kite.
Yeah.
Okay.
That's what I thought.
So you weren't 100% wrong. I think at least. In other words, I'm not sure if a kite can have 4 equal sides. The definition of a kite is that side's equal to that side, that side's equal to this side, and the diagonals are at right angles to one another.
Yeah. Yeah.
And certainly one diagonal here is bigger than the other. This diagonal's 24 and this diagonal's 18. But the other thing about a kite is I don't know if they would call a rhombus a kite.
Me neither, yeah.
I don't think that in the same way that this is a trapezoid.
Yeah.
But if I draw a rectangle instead of this,
I
can't really call it a trapezoid.
No.
In other words, I think a kite, this side has to be different than that side. I'm not 100% sure about that. But
yeah,
this problem, it doesn't matter because you want to use the most specific thing you can use, and a rhombus is more specific than a kite.
Yeah.
A rhombus can only have 4 equal sides. A kite can have all kinds of combinations. What's this?
That'd be a rectangle.
Okay. Yeah, I guess it does have to be a rectangle. Okay? 16.
That'd be a square.
Okay. Now, it is proper to say a square is a rhombus. Right? It fits all the definitions of rhombus. 4 equal sides, the diagonals meet perpendicularly in the middle.
Yeah,
and
exactly.
Opposite sides, it's also a parallelogram.
Okay.
Go on.
Okay.
That picture right there?
Yeah.
How much is x?
Let me see. So
the x. This line here is what?
The mid segment.
Okay.
The midpoint. Yeah.
Okay. How do you get the midpoint?
You add up the 2 sides on the outside, then divide it by 2, right?
2 bases.
Yeah. So it'd be 21 divided by 2.
Okay. That's all.
Yeah. Yeah. Okay.
Let me go to my next page here.
Okay.
let's look at number 1.
Okay.
I don't think I need to draw that. What that says is triangle JKL. JK is congruent to KL, and that's congruent to JL.
Yeah.
What kind of triangle is
that? Wouldn't that be an isosceles?
All 3 sides are equal. Notice
so
it didn't just give me 2 sides equal to one another.
Yeah. So if all 3 sides are equal to each other, that'd be a scaling triangle, wouldn't it?
No. Scalene is 3 different angles.
3 different angles.
In
other
words, scaling, you rarely use that term in geometry. You'll rarely encounter it, other than in a description kind of way. In other words, they may want you to know what a scalene triangle is, but it's rare that you ever talk about it because there's nothing about it that we can do anything. If I say I have a right triangle, then you know there's a 90-degree angle in it.
Yeah.
If I say I have an equilateral triangle, what does that mean?
Equilateral means like all 3 sides are equal to each other.
So isn't that what this is?
Yeah, so that'd be an equilateral. Okay, that makes sense.
Which statements are true? Is statement 2 true?
Nope. No.
What does equiangular mean?
Equiangular is when all the angles are equal to each other.
Okay. Remember something about triangles. This is the key thing. The largest angle is always opposite the largest side. So if I have 6, 7, 8, this is the smallest angle. This is the next smallest angle. And that's the largest angle. Okay, you with me?
Yep.
So if I have a triangle that is 6 and 6, what must these angles be?
If those are 6 and 6.
Not numerically. How do they relate to one another?
They're equal to each other.
Very
sides
important.
are equal.
Very important. If you got sides that are equal, you got opposite angles that are equal. So if I make it equilateral, what's this angle have to be?
If it's equilateral,
the same.
Yeah, so that'd have to be 6
those 2 angles. The key thing is knowing that they're all the same.
Okay.
If I have 3 equal sides, well, I can't have one angle be different than another because I wouldn't have the smallest angle opposite the smallest side anymore. So this picture is an important picture to understand.
Yeah.
If I've got 3 equal sides, I have to have 3 equal angles. And if I happen to have 3 equal angles, they're all 60. But that's not really the important part. The important part is to understand that they're all equal angles.
Okay, cool.
Number 3, is that triangle regular?
Yeah, it would be. Yeah, because all 3 sides are equal to each other. And
all 3 angles are equal.
All 3 angles, yeah.
The definition of regular is really holding my tongue not to crack a joke. But the definition of regular is all angles are equal. In other words, it's equilateral and equiangular. Okay. That's the definition of regular. Whether it's 4 sides, 5 sides, 8 sides, doesn't matter. Yeah. All sides are equal, all angles are equal.
Okay.
So 1, 2, and 3.
Cool.
Now let's talk about the picture in number 2. What kind of shape is that?
So find the value of x. It's a quadrilateral, but
is it
would it be?
Is it a special quadrilateral?
Yeah, it's special.
What?
Would it be?
Special one is it? Remember, the special ones have to have parallel involved, or you got to have at least one set of parallel lines involved. Notice that all 6 special quads, squares, rectangles, rhombuses, trapezoids, kite's the only one that doesn't have parallel involved.
Yeah.
Every other one has parallel involved. Anything parallel here?
No.
So this is not a special quadrilateral. So
no, it's true.
Very little about this. I can't say anything about the sides. What can you say about a quadrilateral in general? There's really only one thing you can say.
All four sides have to equal 360.
All four sides, all four
angles.
Angles.
Yeah.
Have to equal 360. Well, that means I can say that plus that plus that plus that equals 360. There's only one variable. There's no y. It's all x.
No.
So once I come up with that one equation, I'm going to be able to solve it for x easily.
Okay, cool. All right.
What kind of shape is this?
Number 4? Oh, number 3.
Yeah.
That'd be a rhombus. Well, no. That's parallelogram.
Good.
Yeah.
What can I say? What can verbalize an equation that I can?
AB is
because it's a parallelogram.
AB is congruent to DC, and then
stop just a second.
Okay.
Do you see any side measurements in this picture?
Oh no, I don't.
All about angles.
Yeah.
So we don't care if AB is congruent to DC. Let's talk about the angles involved. What angles are congruent?
7p minus 8 is equal to AP minus 17.
Correct. A is congruent to C. Now, once you solve, and that's going to allow you to solve for P, right?
Yeah.
Now, how do I solve for angle D? What do you just give the general equation.
6. Ooh, it's P and Q.
A plus D equals what?
A plus D is equal to 180.
That's all I need to know.
Okay.
Okay? Because we know what P is now. We solved for P already. You have to solve for P before you can solve for Q. Notice, you can't solve for Q, and I can't even start by saying this plus that's equal 180. That's one equation, two variables.
Yeah.
I'm not going to be able to solve for that. But as long as I have one equation, one variable, I'll solve for that variable, and then it won't be a variable anymore. I can fill it in, and I can say whatever that angle is plus that is 180, and then I can solve for Q.
Okay, cool. Cool.
How about number 4?
Like the diagonals of a parallelogram. They must be parallel. Or no, they must be.
Read all 5 before you answer.
Bisect each other. Parallelogram, they'd have to bisect.
Very good. I was going to say, let's go through each answer, starting with, are they congruent?
Nope.
Are they parallel?
No.
Are they perpendicular?
Not
of a parallelogram. If it was a rhombus, they would be.
They would be,
but not a parallelogram. And they bisect each other? Yes.
Yeah. Okay.
Hold on. That last choice is an interesting choice.
Yeah.
Can I draw a parallelogram where the diagonals are not longer than the sides?
Well, no, because it has to be like on the inside of the parallelogram.
Not both diagonals don't have to be longer than the sides. The long diagonal does, but notice if I drew a parallelogram like this, that short diagonal is not longer.
No, it's not.
The sides. This is the longest side right there. The long diagonal is always going to be longer than the longest side.
Yeah.
Not both diagonals.
No.
All right.
Okay.
This is good practice. I should have done this before. Although the last half-hour session we had where we talked about incenters and circumcenters and those.
Uh-huh.
I hope that's what's coming up next in geometry, because
Yeah, me
that's
too.
going to be hard. That's hard to memorize. You
Okay.
really almost have to have a method for memorizing, and I really would like to help you with that.
Cool.
And so the sooner it comes up, the better off you're going to be, because you've already had a half-hour session on it.
Yeah, exactly.
So let's see. We have a session for Monday? I think we do. Hold on.
Okay.
This Monday, I got you down at 7.
At 7, yeah.
Okay. So
Okay.
you will have had one class, right, by Monday night?
Uh-huh.
Good.
I think
You'll
so, yeah.
be able to tell me what's coming up next.
Awesome. Sounds good.
We could use a little bit more review on quads. But you'd probably be better off, since you've already been tested on that. You're not going to get tested again until, well, you'll get tested on quads in another 3 weeks, won't you?
I think so, yeah.
You'll have to take a semester final. So you're not done with quads by any means.
No.
But it'll also probably cover whatever you're about to cover.
Yeah, probably.
All right.
All right, awesome.
I will talk to you Monday.
Sounds good. Thank you.
All right, Dylan. Have a good one. Bye-bye.
You too. Bye.